this form. In this case, let's just go for factoring. In this case, our factors would be x minus 6, x plus 1, all being equal to 0, given that that is already in standard form. Right? From here, our zero product rule, which states that if I have a times b being equal to 0, that means either a is equal to 0 or b is equal to 0. What that means for this equation, obviously, is that x minus 6 being our a is equal to 0, or x plus 1 is equal to 0. Thusly, x is equal to 6, or x is equal to negative 1. If we take our two little linear equations and simplify them to their utmost. As far as the mark allocation is concerned for something like this, well, you would get a mark for factoring, and then I'd assume 2 for the correct answers, obviously. Moving right along. Well, when you see the phrase correct to 2 decimal places, that means don't even try to factorize. However, it is still a quadratic and the rules still apply. We need to put this in standard form, which means, well, we're just going to have our good old-fashioned foiling going on. So at the top we'll have 3x squared, and then minus 12x, minus x for the first one at the bottom, and then plus 4. However, we have to transpose that 16 by subtracting it on both sides. That's supposed to be a plus 4. Apologies, early mistakes. So that's minus 16 equal to 0. That brings us close. So we'll have 3x squared minus 13x and then minus 12. And as previously stated, any examiner worth his salt, once they place that there, it means this is not factorizable. So now we've done our first job, which is put this in standard form. Of course, it says it's equal to 0, and then we have descending powers of x on the left hand side, with 3 being our a value, negative 13 being our b value, and negative 12 of course is our c value. Why is that important? Well, it's supposed to go in the famous or infamous quadratic formula. Well, infamous if you don't like it, of course. Of course, we've all seen the memes on the internet, but there it is, and its use is quite simple. Well, we'll have x being equal to minus, obviously, negative 13. That's substituting the b, plus minus square root of, well, b squared minus 4 times a times c, and then we'll obviously still have to divide that by 2a. Yeah, obviously we're going to need the value over there. So let's just, for funsies, put it in another color. So negative 13 belongs over there, our a value belongs over there, and our c value belongs over there. Well, that's still our a value, and then drums please, because x is equal to either 5,1,1 or x is going to be equal to negative 0,78, and these of course are rounded off to our standard 2 decimal places as we are normally instructed on our instruction sheets, maybe the first or second page in your question paper. Well, as for mark allocation, getting this thing to standard form deserves a mark, and then substituting the correct values into the formula. You don't get a mark for using the correct formula on its own, because you've been provided with a formula sheet. You're in grade 12, and then obviously your answers deserve another mark. Well, see, on our little preparation test, looks like this. Now it functions very similarly to an equation. We still have standard form, but instead of an is equal to sign, we have a greater than or equal to. with 0 still on the right hand side, and the rest of our standard form being apparent in the expression on the left hand side being in descending powers of x. We shall then factorize this, hopefully correctly. So for this we'll have x minus 5, x plus 2. Here's where the difference comes in. We now have critical values, not curriculum vitae, but those critical values will have us have x being equal to 5 and x being equal to negative 2, because both of them are critical. There's no or here. So why critical values? Well, because if we were to draw this expression on the left hand side, x squared minus 3x minus 10, as a parabola, we'd see that negative 2 would be the one x-intercept and 5 would be the other one. So this represents an x-axis. So what makes this tool so useful? Well, above the x-axis is where our y values are normally positive, so that's where we'll find the greater than and equal to values, and at the bottom we'll have the less than and equal to values. And this helps us construct our answer, because as we can see, we are dealing with an inequality that wants to know where we are going to have y values greater than, or where this expression is above the x-axis. So that shadow falls over there, and the shadow on the left falls over there. So obviously these x values are less than or equal to negative 2, or as we can see, these x values are going to be greater than or equal to 5. That's as simple as that thing gets. For mark allocation, obviously getting this thing to standard form deserves a mark, and then we can consider that our methodology, and then obviously having constructed the correct answer deserves a mark as well. Let's keep moving. So as far as this is concerned, we need to be careful here. We have a radical sign or a square root operating over there. Now it's worth noting that this is obviously positive, which does become important in terms of the answers. But let's get going. So first things first, this equation is rather comfortable because it allows us to immediately square both sides. So 3 squared is equal to 9, and the square root of x is nothing but x. The left hand side, need to be careful. If we square that, we're going to have x squared minus 8x plus 16. Now it's obviously going to be easy to transpose that value by subtracting 9x from both sides. So we'll have 0 on the left hand side, and on the right hand side we'll be left with x squared minus 8 minus 9 gives us minus 17, and let me fix this value over there, and that's minus 17x, obviously plus 16. That is rather simple to factorize, because we'll have x minus 16 and x minus 1. Those are going to be our two values. Thusly, x is equal to 16, or x is equal to 1. And then let's not forget the fun part, which guarantees our last mark. We need to do some testing. So if we use 16 on the left hand side, we'll have 3 times the square root of 16, which is just 3 times 4, which gives us 12. And then on the right hand side, well, 16 minus 4 also gives us 12. Also gives us 12. These match, so that's perfectly fine. If we test 1, we'll just have 3 times 1, which is 3. But then on the right hand side over there, we'll have 1 minus 4, which is equal to minus 3. So that makes that solution up. So this value is invalid. So let's just see what that does for our mark allocation. So a good proposed mark allocation over here would look like that for simplifying to standard form. factoring, 1 for your answers, and then a mark for testing or validating your solution. Moving right along. No question 1 is complete without some simultaneous equations. Well, in this case, let's just rewrite them first. So we'll have 3x minus y being equal to 2, and then we'll label it with a number. We'll call it number 1, and then we'll have 2y plus 9x squared plus 1 all equal to 0, and then we'll apply another label over there, call it 2. That allows us to give ourselves some nice instructions in our step-by-step methodology for solving the system of equations. So from equation 1 we shall transpose the y, or add y on both sides, and then subtract 2 on both sides. So minus 2, and obviously minus 2. We want those to cancel, those to cancel. So if we read carefully, we shall have that y is equal to, well, that just states 3x minus 2. And then a neat little trick I learned from a very, very masterful and capable teacher is to literally box the solution, because this is like a general solution, and it's so important that we give it its own label, 3, because our very next instruction to ourselves says substitute 3, or equation 3, into number 2. Well, you can't go back to number 1. Yeah. Thusly, we shall have 2, well, y is equal to this, but let's just make a set of brackets over there. Let's just have a set of brackets, and then we still have 9x squared plus 1, that's all equal to 0. So now we can fit our 3x minus 2 into the equation and do the actual substitution, because that's what the method is called. Well, from there, let's get an even more different color so that we can just do some simplification. So we'll have 6x minus 4 plus 9x squared plus 1 all equal to 0. Let's do some rearranging. It gives us 9x squared plus 6x, and then 4, negative 4, and 1 gives us minus 3. That's all equal to 0. Nice. In standard form, because we have descending powers of x squared, x to the power 1, and then constant, all equal to 0. All components of our standard form, of course. Well, from there on, the astute amongst you will have noticed that all the coefficients and the constant are multiples of 3. Hence, we divide the entire equation by 3, rendering it like this. That then becomes factorizable. 3x minus 1, then we'll have x plus 1 all equal to 0. I'd be remiss to say that, well, if the factorization presents a problem at any point, anywhere where you have a quadratic equation in standard form, that's what the formula is for. Never be shy, don't be time wasty. So over here we'll then have x being equal to 1 over 3, or x being equal to negative 1, and then obviously our y values are also required. We'll have y being equal to negative 1, of course using equation number 3 to solve for y. And then obviously our other value will be y being equal to negative 5. Again, let's just see what the marker will do with this. Well, obviously for that general solution, that's fine. Substitution deserves a mark. And then simplifying into standard form. And then obviously obviously our solutions, one each. That should give you the full complement. Next, here's a category I call either you see it or you don't. Why would I say that? Well, there'll always be one problem that's designed to test depth of theory, and if it happens to fall within your wheelhouse, you're good and prepared. If it doesn't, hopefully it's not something worth crying too much about, because there's always a next time, and hopefully the real win would be piquing your interest. I wonder how that gets done. That in and of itself, as far as I'm concerned, is winning. Well, now that we've copied over the question, well, the key over here, let me get another color, is going to be this exponent. And in this case, the reason would be it's the lowest power of 2 that is present inside this expression. So why is that important? Well, if we can have a look at our first simplification, which would come from our first exponent law, which states that if I have the same base and I am multiplying exponents, all I have to do is add them up. What's fun about this is that you can read it like you read Arabic, from right to left. It applies in that direction too. And that is important because 2 to the power 1002 can be rewritten as 2 to the power 998. And what do I need to add to get to 1002? Well, 2 to the power 4. We can see that these two exponents add back up to that. And then, of course, for the other term, we'll have the exact same thing, 2 to the power 998 times, let me just extend this radical, my apologies. Well, to get to 1006, that needs to be 2 to the power 8. And that's all divided by 17 multiplied by 2 to the power 998. Some of you will already see where this is going, so let's just get there. Well, I have just created for myself a common factor of 2 to the power 998, of course, and that is multiplied by what's left over here. That would be 16, and 2 to the power 8 is 256. Oh, that's 2 to the power 998 multiplied by 17. Those, of course, anything divided by itself is equal to 1. So now we'll have the square root of 272 over 17, which is square root of 16, and that's of course equal to 4. As far as this concerned, that part and the 256 part, it would be helpful to leave some hand calculations for your marker, in case they might be pedantic about without the use of a calculator bit. So over here, something like this would do. That obviously is 1, 10, subtract 17. Nope. 17 there. That becomes 10. 102, and then obviously 6 times 17 is 102. Or you can show that you multiplied or applied multiples. As far as 256 is concerned, well, 2 to the power 4 is equal to 16, and 16 times 16 gives us 256. So just leaving some hand calculations around the place might be a good idea. Doing that, creating that common factor, that deserves a mark. Well, and then basically the simplifications and the final answer is what gets you the rest of the way. Hopefully that's fun. If it's not, don't call me. Just joking, guys. Well, the next term in the sequence is generally the first thing. But what I like to do, as soon as I see the word quadratic sequence, is I jump straight for the general or the nth term. So in this case, we need to do what we normally do. That's 2, 3, 10, 23. And let's just have a look. It's 1, 7, 13. And then we can see over here our second difference is constant, as it should be, because it's 6 all the way. So from there we have 6. Well, that's going to be 19. That gives us 42, which is the answer to A. Well, that gives us enough information to get into generating or determining the nth term. So let's get going. Well, we know that 2a is equal to 6, so let's set that up. Therefore, a is equal to 6 divided by 2, which is 3. Then we shall have 3a plus b being equal to 1. So that's just 3 times 3 plus b being equal to 1. And then we subtract 9 from both sides. That obviously zeroes out. Therefore, b is equal to negative 8. You can make that 9 a bit nicer. Of course, that might be slightly uglier. So a plus b plus c is equal to 2, coming from there, of course. And then subbing our values, we have 3 minus 8 plus c. That was subbed in. And that's obviously equal to 2. That is minus 5, which means when we want to finally resolve, we need to add 5 to both sides. And let us not forget we were calculating the value for c. That's 0, and 2 plus 5 is equal to 7. These are, of course, not the answer. They are the results of our calculation. They wanted the nth term, so let's give it to them. Or me. I don't know if that's safe enough. So it's 3n squared, because that's the value of a, minus 8, that being our b value, n plus 7. That's fine. Mark allocation, in this case, pretty straightforward. 1 mark for a, 1 mark for b, 1 mark for c, and 1 mark for giving or answering the actual question. I think we're moving along quite nicely, ladies and gents. Calculate the 17th term. These would be some of the more straightforward versions of these. So the nth term we have, but that's not what we were being asked to do. We want the 17th term, t17. It's going to be equal to 3 times 17 all squared minus 8 times 17 plus 7. And any trusty calculator will give you the value 738. 1 for subbing, 1 for your answer. Well, the first 3 terms of this arithmetic sequence is number 2.2a are as follows: 2p plus 3, p plus 6, and p minus 2. Now, given that this is an arithmetic sequence, we do know that it has a constant or common difference. Which means what? Well, we use this bit of theory. Term 2 minus term 1 is going to be equal to term 3 minus term 2. And if we extend it, we'll have term 4 minus term 3, and then term 5 minus term 4, and so on and so on ad infinitum. What does that mean for this sequence? Well, we have term 1, we have term 2, and then we have term 3. So it just requires a bit of careful setup, which renders p plus 6 minus, and then I like to use brackets, 2p plus 3 being equal to p minus 2 minus p plus 6. This simplifies to minus p plus 3, because we have p minus 2p, that gives us that, and 6, remember, gives us 6 minus 3, then gives us positive 3. P minus p zeroes out, and then minus 2 minus 6 will give us minus 8. So we'll have minus b being equal to minus 11. And if we multiply or divide by negative 1 on both sides, we get what they wanted. They told us to show them that p is equal to 11, and we have shown it. Now the mark allocation that I gave over here is probably on the stingy side, I will admit. So setup and simplification, and then the answer. A generous marker will give probably something extra. I didn't feel that generous when I was setting this. Sorry, I apologize for that. Calculate the smallest value for n, the smallest value of n, for which the general term is less than negative 55. Now remember, it's b, so it is still related to the sequence we got over there. Now we can see over here that that common difference, if we punch in that 11, is going to be minus 8. How so? Well, 2p is 2 times 11 is 22 plus 3, that gives us 25. 11 plus 6, that's 17, and then 11 minus 2, that gives us 9. So 9 minus 17 gives us minus 8, and 17 minus 25 also gives us negative 8. So how do we determine our Tn? Well, you can use the formula sheet. You're always welcome to that. But that's minus 8n, and if I put n equal to 1 in there, I have minus 8. How do I get to 25? By adding 33. Or 25 minus minus 8. That also works. That's our general term, but that was not what was asked. We want the general term to be less than negative 55, because we want the smallest value for n, which gives us the first term less than negative 55. That's our setup. Solution is quite simple. You just transpose that 33 or subtract it from both sides. That gives us negative 88, which means if I subtract or divide by negative 8 on both sides, well, I get an n, and on this side we'll get an 11. But remember what happens to an inequality once you divide or multiply by a negative. It flips. So smaller than in this case becomes greater than. So n needs to be greater than 11. Now remember, when it comes to a sequence, n is an integer, and a positive integer at that. Therefore, the smallest value we're looking for cannot be 11, because 11 will give us exactly negative 55. N needs to be equal to 12. So in terms of our mark allocation, this is definitely worth a mark, and the other two, sadly stingy, will be allocated in between the rest of your calculations. Right. Geometric sequences. Base theory. Common ratio being equal to T2 divided by T1, which should be equal to the third term divided by the second term, and so on and so on. So if we can just go a little back, the link obviously being with arithmetic sequences we are subtracting, whereas with geometric sequences we are dividing. So without any further ado, determine the value of the common ratio. Negative 18 divided by 36, that gives us negative 1 over 2. So, or we can use those two, because that's legal. Well, that was apparently worth a mark. If I can flip my marking guideline that I have in front of me over. Yes, I worked one out. Preparation is key. Well, first off, we need Tn, and I've provided formula sheet. Should have this written somewhere over there on the page. So it's just a question of correct substitution. We have the value of R, we have the value of AE, of course. Hence, Tn is going to be equal to 36 multiplied by negative 1 over 2 all to the power n minus 1. Well, that gives us Tn, and that needs to equal 9 over 4096. So, doing a mix of method and smart calculator work, this shouldn't present that much of a problem. Well, we'll divide both sides by 36 to start with, which means, okay, so we divided both sides by 36. 9 goes in there once, goes in there 4 times. So that 4096 times 4 in your calculator will give you some result. And then we just use the second function and the factorization or prime factorization function that it provides. Pattern looks something like this on a Casio. With that written on top. That should give you 1 over 2000 and 1 over 2 to the power 14. Okay, so that's good for now. And then of course what we were left with on the left hand side was this, n minus 1. So using our exponent laws on the left hand side, we'll manipulate this. Into that, and that can turn into 1 over 2 all to the power 14, if you will. So now that we've dealt with that, what are we going to do with this? Well, anything to the power negative 1 can be reciprocated. So we'll end up with negative 2 to the power 1, which is easier to divide everything by. Which means on the right hand side we'll now have 1 over 2 to the power 14, and then that will be divided by 1 over 2 as well, and then we can take that negative out because it's to the power 1. So let's leave that positive. Okay, so let's do that again just to make sure it sinks in. Anything to the power negative 1 can be reciprocated. So then that makes sure that we've acknowledged the negative in the exponent. So this 2 taken differently can be written as negative 1 times 2. So if we divide by 2 on both sides, we are multiplying by half, and then also we need to acknowledge the negative in the scenario. So let's just go on linearly. We'll have minus 1 over 2 all to the power n being equal to negative 1 over 2 to the power, well, if you put this in brackets, 14 plus 1 gives us 15. Now, given that this is uneven, we will render the same negative result if we were to do this. Negative 1 over 2 times 15, because once the exponent is uneven and there's a negative in the base, the n value will be negative. But this ensures that our bases are the same, and then we can finally state that running out of space, or I have run out of space some time ago, but no matter, n is equal to 15. Radio, still owe you guys some mark allocations for this one, as previously stated. Well, for this one, it's a simplification from the formula. That will give you 2 marks, and then obviously n being equal to 15, our final answer, gives the final mark. Determine the sum to infinity of this monster. Well, again, this is a formula sheet question. A being equal to 36, and then 1 minus negative 1 over 2. So simplification will give us this divided by 3 over 2, and your calculator should give you an answer of, if I'm not mistaken, 24. 2-mark question. Subbing in the right formula, final answer. That is as simple as that ever gets. Now the next one wants to look complicated. It's trying really hard to look difficult. However, the astute amongst us, first thing to acknowledge, it's dealing with that sequence. So as we can see over here, well, the numerator is made up of all the uneven numbered terms, and the denominator is made up of all the even terms. So what we have is a sum of 250 terms, both in the numerator and the denominator respectively. However, for the numerator, we should take note, given that it's every second term, our common ratio, that is term 2, and 9 divided by term 1, which is 36, gives us 1 over 4. Then we have our A value, and that's going to give us a general term of, well, 36 times 1 over 4 all to the power n minus 1. And then for our denominator, well, for that we'll have dn being equal to negative 18. Well, this value is going to be negative 9 over 2, because we're going to divide it or multiply it by minus half. Now, double checking this in your calculator, we should see that r for that denominator is also 1 over 4, and then we'll have n minus 1. So, back to the actual problem now that we have some general terms from whence we can just grab information as required. Well, what did we say? That is the sum of 250 terms. That is also the sum of 250 terms. Because what's happening here? Well, all the uneven terms are at the top and all the even number terms are at the bottom, but that's the last and highest number that we can spot, and 500 divided by 2 gives us 250. So there was no thumb sucking. So the formula in question required for the top and bottom is as follows. The sum to n terms, we have a, and then we have 1 minus r to the power n, all over 1 minus r. We're going to use that for both the bottom and the top. Bottom and top. So our sum is going to be equal to, well, let's lay it out, 36 multiplied by 1 minus 1 over 4 all to the power 250 divided by 1 minus 1 over 4, and then for the bottom part we'll have negative 18 multiplied by 1 minus, again if we do our substitution correctly, it's 1 over 4 over the power 250, close bracket, and then we have 1 minus 1 over 4. Oh, might as well bracket our substitutions. So now we need to just have a look at something. That part is identical to this part, and as we are well aware, anything divided by itself is equal to 1, and 36 divided by negative 18 is negative 2. Don't fight it. If you did it correctly, that works. Mark allocation for this. Well, you should get some marks for setup, and then substituting in the correct formula, and then the final answer. Hope that was informative and not too boring. Hello, arriving at question 3 with a slightly different and darker design aesthetic, given that that's a blackboard. Well, over here we have a computer server valued at 24,000 Rand, depreciating at 18% per annum on a reducing balance. Determine the value of the server after 3 years. Well, reducing balance tells us that this thing is reducing using the following formula: A is equal to B 1 minus the reducing part, I all to the power n. Okay, so we have to use our compound formula because we say reduce. That reduction gets compounded as the years go on. Well, in this case, our P is equal to 24,000, and we have 1 minus, of course, we'll take that 18%, divided by 100, and then, of course, over 3 years. Calculator should give us 13,232 Rand and 83 cents, because we are living in South Africa where the currency is Rand. Determine the annual effective interest rate of 14% interest compounded monthly. Well, there's this fun little formula that you're required to remember, I think, and that's equal to 1 plus I to the power m over m, and that's all to the power m minus 1, where this m relates to our nominal interest rate and the conversions we do over there. Well, I've also seen this being written with a plus 1 over here. However, this is the version I like or prefer. Use it in the form that you were taught. I'm always a proponent of that. However, as far as the sum is concerned, that's quite simple. 1 plus what happens to our interest rate? It's 14%, so that's 14 divided by 100. You can also use the decimal value. Remember, compounded monthly, how many months in a year? 12. Again, that needs to go into our exponent as well, minus 1. That entire expression is ready for your Casio. Ooh, should I mention brand names? Maybe I'll bleep that out. Okay, in any case, your answer should be 0,115718 and so on, which will round as an interest rate 11,57%, rounded off to 2 decimal places. That's what I wanted to say. In any case, let's go to Dan. Dan invests money at an interest rate of 8.5% per annum, simple interest. How many years will it take for his money to double? Well, we know what simple interest rate formula looks like. That's going to be A equal to P 1 plus I n, or I multiplied by n. Now, Dan's money is going to double, which means the A value is going to be equal to twice the principal value over here. And that's what I'm going to apply. So that's 2p is equal to the principal value. It's 1 plus, what's the interest rate Dan's working with? 8,5 over 8,5 over 100. That's obviously multiplied by n, which is what we are trying to solve for. Well, from there, we can divide both sides by p. We don't need that anymore. And given that p is away, what we're left with is 2 being equal to 1 plus, well, 8,5 over 100 n. Subtract subtract 1 from both sides. Then we just reciprocate in terms of our multiplication. So n is now equal to, well, like I said, we multiply by the reciprocal, which gives us those cancelling, and on this side we did the exact same thing, multiplied by 8.5 over 100. So that's exactly what n is equal to, because 8.5 times 100 multiplied by 1 is itself, and that's just equal to 11,76 years is what n is basically measured in this case. So that's roughly 11 years and 9 months. Probably some days added in there as well, but I think that should be good enough. Think of a year is probably one of those cases where I was a bit generous, but realizing that, using the correct formula, simplifying, and your final answer is basically the thought process over there. If your teacher disagrees with me, they are probably right. Now, the final one asks us about an investment. Now, final financial question. Well, 2,850 Rand is invested at 8% interest compounded quarterly. After 9 years, the interest rate changes to 10.5% per annum, compounded monthly. How much is the investment worth after 15 years? Well, this is where we talk about something called a timeline. So let's see if I can get a line shape going over here. Wow, that's a nice line. It's straight as well. Okay, so how do we deal with the timeline? Well, any timeline starts at 0. Okay, now the day the money is deposited, and then at some point after 9 years, time period 9, there's some change that happens, and of course they want some value over here to be given after 15 years. So let's see what happens. Well, we have for the first period, which runs from T0 to T9, we have an interest rate of 8% compounded quarterly, which means that needs to be divided by 4, which is 8% is 8 divided by 100. If you use your calculator correctly, you'll get something like that. Of course, these 9 years need to be multiplied by 4, because there are 4 quarters in a year. So our n over here is going to be 9 times 4, which is equal to 36. So now we have that information over here, and that is good. So for the last period over here, we need to firstly make sure we have n being equal to 6, but the compounding happens monthly, so that's times 12, which is equal to 72. And then of course our interest rate, which is 10.5 divided by 100, needs to be further divided by 12. So we are sort of ready. Now remember, from T0 to T9, our A value becomes a new P value, and then this P value becomes the new P value, the new A value. I can do better than that. This P then becomes the new A value for that, which is why we can write this as such. Now remember, the formula we're going to use, because we are compounding and this is an investment, is going to be A is equal to P, which is our principal, and then it's 1 plus I to the power n. So let's do that for this formula. What is our principal value? 2,850. 50 Rand, and then it's 1 plus what is the interest rate that we are using, that value over there, which is 8 over 400, and that is all to the power 36. Now we can do this calculation first and then take that value and replace it and do a second calculation, or we can be efficient about it, and let's be efficient in a different color. We can realize that this is a 1 and that this calculation gives us a new principal. This is principal value 1. The entire calculation gives us, we can do that even better, we can have a look at that as principal value 1. This entire calculation gives us principal value 2, and that just needs to be multiplied in the new calculation as such. 1 plus, what's our interest rate, 10.5 over 1200. That needs to be raised to the power 72, which will give us a final value of 10,889 Rand and 77 cents. Okay, so one more time. Well, first we need to establish our timeline correctly so that we can see whether we have calculations that need to be broken up, how they need to be handled. From that, in this case, we saw that our first calculation in yellow just happens to be what we need to get the second principal value, which we need in the second calculation, and thus combining the two calculations, we then have that principal value multiplied with that calculation, and that gives us our final answer. We can always split the calculations where we do this one first and then we take the answer and multiply it with that factor over there. Either is acceptable. This though is more efficient with enough practice. A final word on the financial mathematics over here is that well, let's give you your mark allocation for all your information set up correctly and substituted. You should get those marks and then a final mark. Also, I might have been slightly generous over here, not a problem. For June months, generally speaking, you are only tested on grade 11 financial mathematics in your common papers. If it's not so, then your specific district, the teacher will mention it. It depends on what part of the syllabus you have finished, but here in the good old Eastern Cape, that's generally the case, or has been the case for the past few years. Finally, we can move on, I think. Well, we needed to get bright at some point. Let's have a look. What do they want? So for any question with a diagram first, let's just examine the thing. So we have two graphs intersecting at 0 and 2. Well, that's that y-intercept over there. And G, which is parabola, touches at 3 and 0. So we know that's 3. The coordinate of B lies on the graph of F. That's indicated. And well, here we have two equations given with some unknown constants in there. Well, what does that mean? Well, first they want us to determine the value of K and Q. Well, let's have a look at it. The value of Q is inside over here. That is, if we remember our turning point formula, that is just a horizontal movement of a parabola, and it's moved how many units? 3 units to the right. So that's something I can see. So for A, there's no calculation involved. depth of theory, so Q is just equal to 3. How about the value of K? Well, we are in luck. We can do a double substitution into f of x, or yeah, in f of x. Well, seems our diagram is a bit of a problem. That's on me, so apologies for that. So, but we will call it f of x in this case, and then just say a, let's try that again. Seem to have lost my way slightly. Well, a 0 and 2, using that as our substitution value, we can say 2 is equal to K 0, which is our other substitution value coming from there, minus 3 all squared. Okay, so we are using that equation over there. Hence we'll have 2 is equal to, well, negative 3 squared is just 9k. Thusly k is equal to 2 divided by 9. Secondly, B, determine the value of A. So we know that g of x is equal to 2 multiplied by a to the power x. And then of course we do have a value over here that we can substitute, that b being a y value left hand side, and there's 2 a to the power 1 because that's the x value given over there. So that's just 2a. 5 is just equal to 2a. What does that mean? Well, divide both sides by 2. So a is equal to 5 over 2. Mark allocation for these, well, pretty simple. For Q, substitution, final answer. And then over here, again, substitution and simplification, final answer. And that's about as simple as that gets. Moving right along, as they shall say. Well, C, explain why the inverse of G, well, now I've got it right. This is just bothering me. Apologies to everyone involved. Is not a function. Well, why is it not a function? Well, if we invert it, it's going to look something like I shouldn't be wasting time with this, but in any case, that's going to be over there. Yeah, at least the bottom part. Okay, well, what's the usefulness of that? Well, quite simply, if you look at the inversion, it fails the vertical line test. So one way of putting it is G fails the horizontal line test, or the inverse of G fails the vertical line test, or we can say the inverse of G is a many to one function. Anything that makes theoretical sense as far as inverses is concerned would be deemed acceptable and gain the full 2 marks. Well, write down 2 ways in which the domain of G can be restricted in order that the inverse of G is a function. Well, we need the turning point for that, because if we only have a rising function, or I can change colors, a function that descends from left to right to that point, what we'll have is that, of course, it's going to split, and then that part over there will pass the vertical line test. Or we can do it the other way around as well. So to answer the question, then we can say let x be greater than or equal to 0, not 0 because it's the domain, the turning point, so x needs to be greater than or equal to 3, or x needs to be less than or equal to 3. Either of those restrictions will make g a function, or the inverse of g, I should say. Radio. For number E, then, color's bothering me. I need something a bit better. How about orange? I think orange is better. Well, determine the inverse of f in the form y is equal to. Well, for the inverse of f, we'll have what? X being equal to x being equal to a few moments later, x being equal to 2 over 9, because we're taking this f. Now if you take this f, I'm probably going to have to do that as well. Y minus 3 all squared. Therefore, we shall have y minus 3 all squared being equal to 9 over 2. And remember, that's multiplied by x because we multiplied both sides by the reciprocal. And then we square root both sides, so we'll have y minus 3 being equal to plus or minus the square root of 9x over 2. Therefore, y is equal to 3 plus minus the square root of 9x over 2. Well, there we have the inverse of f completed. However, if it's g of x, the process is exactly the same. Let me just do it in a different color. So for that one, we will say that x is equal to 2 times, well, 5 over 2 to the power y, which means we'll have x over 2 being equal to 5 over 2 all to the power y. And then we need log. Well, so therefore y is equal to log, and then we'll have a base of x 5 over 2. Let me just fix that. And I'll have y being equal to log with a base of 5 over 2, and that's applied to the number x over 2. And that's good enough. Well, what is the defining equation of h? If h is the reflection of g in the y-axis. In this case, if we're talking about that g, what will happen is all the x values will change sign. Therefore, we shall have h of x being equal to 2 times 5 over 2 to the power negative x. And then as far as this one's concerned, if that's the h of x. Because of the confusion, I'm doing both. And it's confusion that I created, so I deserve this punishment. So it's 2 to the power 9. And then we shall have, remember, the x values need to flip. Okay, so in that case, we're just going to end up with x plus 3 all squared. Because the x's will become, what we'll have is negative x minus 3 all squared, and if we take a negative out, we'll have negative 1x plus 3 all squared. So that's how that calculation works. Hence, negative 1 times negative 1 becomes positive, and we end up that or that. Damn you, lack of accuracy. Okay. Is f an increasing or a decreasing function? Give a reason for your answer. Well, f is decreasing. And the reason would be, well, quite simple. Our y values decrease as we move to positive infinity. Or you can say base is less than 1 and greater than 0. Radio. Let's see if this worked. Determine the inverse of f in the form y is equal to, well, there we have our function as it sits. So all we have to do is flip x and y. So x is equal to 1 over 3 all to the power y. Therefore, just put the b over there. Therefore, if we apply our log, we'll just have that y is equal to log, and the base is 1 over 3, and the number being x. Of course, get our marks there. Next, draw a sketch graph of the inverse of f. Show all asymptotes and intercepts with the axes. In this case, our asymptote, let me make it in a red, is going to come in there, right on top of the y-axis. So one's the value we should mark, and that is as good as that gets. You can use either your table method or your understanding of how this thing should work. Depth of theory is always a good thing to have. Now, for D, our final question. This is obviously C that I pre-prepared. Describe the transformation of f to g if g of x is equal to log base 3 of x. Well, now remember, it's from f. So first thing is reflect in the y-axis, and that'll turn that into a 3 reflection in the y-axis, and then step 1, step 2, reflect across y is equal to x, which is the description of creating an inverse function. And that, ladies and gentlemen, takes care of section A. Hopefully my editing ability has taken care of most of my more egregious mistakes. Hopefully this was informative and editable so that eventually it can be cut up into chunks for question by question utility, I should say. I thank you for your attention, attendance, and attempts at my humble little project and assignment. Stay warm, it's getting cold.